In the vast and silent ocean of the cosmos, where even the speed of light bows to overwhelming gravity, black holes sit as the most mysterious and awe-inspiring entities humanity has ever encountered. These enigmatic titans, cloaked in eternal darkness, represent the very edge of our understanding of physics. They are paradoxes in space, objects so dense that the known laws of reality seem to unravel at their boundaries. For decades, black holes have stood as both terrifying destroyers and irresistible lures for science. They've captured the imagination of theorists and storytellers alike, inspiring questions that stretch the human mind to its limits. What truly lies beyond the event horizon, the invisible boundary from which nothing can return? Is it simply a cosmic prison, a point of annihilation? Or could it be something more, perhaps a passage to another universe, a wormhole, or even a doorway into dimensions we have yet to comprehend? Until recently, these were questions without answers, confined to chalkboards, equations, and science fiction. But with the launch of the James Webb Space Telescope, the most advanced and powerful observatory ever placed in space, humanity has taken a bold step closer to unraveling the secrets of these cosmic enigmas. Since its deployment in late 2021, Webb has astonished scientists and dreamers across the globe. Its massive golden mirrors and highly sensitive instruments were designed to capture faint traces of light emitted billions of years ago. Effectively, Webb acts as a time machine, allowing us to peer into the earliest moments after the Big Bang, to watch the birth of stars, galaxies, and possibly even the first chemical ingredients of life. But beyond the wonders of distant galaxies, Webb has turned its eyes to one of the greatest mysteries in existence, black holes. And what it has revealed is nothing short of breathtaking. At the core of most galaxies, including our own Milky Way, lurks a supermassive black hole. These gargantuan objects are millions, sometimes billions, of times more massive than our Sun. Their gravitational pull is so overwhelming that not even light can escape once it passes the event horizon. Yet, black holes are not entirely invisible. Their presence is betrayed by the chaotic maelstrom of matter that surrounds them, a blazing accretion disk made of gas, dust, and radiation heated to unimaginable temperatures as it spirals inward. This cosmic storm forms the borderland between the known and the unknowable, and it is precisely here, at this violent frontier, that Webb has focused its unmatched vision. In a landmark observation campaign, astronomers pointed the telescope toward NGC 1068, a galaxy sometimes referred to as the hidden galaxy. At its center lies a ravenous black hole, long shrouded by thick clouds of dust and gas that made detailed observations nearly impossible, until Webb. What the telescope uncovered stunned even the most experienced scientists. Webb's infrared eyes pierced the dense cosmic veil, revealing not only the structure of the accretion disk but also colossal jets of particles erupting from the black hole's vicinity. These jets, propelled by intense magnetic fields, stretched outward across space like cosmic lighthouses, carrying signatures of extreme physics, energies so high that no laboratory on Earth could replicate them. The most tantalizing discovery lay not in the jets, but in the patterns of light dancing around the black hole. Using Webb's high-resolution spectrographs, astronomers detected peculiar distortions in the light emitted from matter near the event horizon. These distortions matched predictions for something long theorized but never directly confirmed: photon rings. Photon rings are concentric halos of light that orbit the black hole multiple times before barely escaping. They are like echoes of photons caught in gravity's final embrace, circling again and again before slipping away into the cosmos. Their existence was predicted by Einstein's theory of general relativity more than a century ago, but capturing evidence of them was thought to be nearly impossible. Now, Webb may have seen their elusive glow. But the surprises did not stop there. The telescope also recorded irregular pulses and fluctuations in the radiation surrounding the black hole, signals that defy classical models of physics. Instead of smooth, predictable flows of energy, there were disruptions, strange surges, and quantum-like jitters. Some researchers speculate that Webb may be witnessing the point where quantum mechanics collides with gravity, the very frontier of a long-sought theory of everything. If confirmed, these observations could provide humanity's first clues about how spacetime behaves when it begins to unravel. For generations, physicists have wondered whether black holes are truly cosmic dead ends or could, under the right circumstances, act as bridges to other realms. The idea of wormholes, shortcuts through spacetime, has long lived in theoretical physics and science fiction. Now, with Webb's precision, the possibility feels less far-fetched. The peculiar patterns of light and unexplained pulses hint that the environment near black holes may be far more complex than a simple void. Could we be glimpsing the edges of a hidden structure, perhaps even a gateway? Of course, caution is essential. Webb cannot peer past the event horizon itself. The singularity, the infinitely dense heart of a black hole, remains beyond observation. But what it can do is illuminate the boundary, giving us an extraordinary portrait of the strange physics unfolding in the black hole's shadow. What it reveals is chaos made beautiful, swirling gases, tangled magnetic fields, blinding radiation, and perhaps even exotic particles yet to be identified. One of the most profound implications of Webb's findings lies in how they challenge our understanding of gravity. Newton described gravity as a force. Einstein redefined it as the curvature of spacetime. But near black holes, where density and energy push the limits of physics, neither theory may be enough. The irregularities detected by Webb suggest that something new, something unifying, may be at play. This pursuit of a grand unified theory has been the holy grail of science for more than a century, a framework that can unite the cosmic scale of general relativity with the quantum world of particles. The borderland of black holes may be the only laboratory in the universe where such a unification can be glimpsed. Webb is also helping test the predictions of Hawking radiation, a theoretical process proposed by Stephen Hawking, in which black holes slowly emit particles over vast timescales, eventually evaporating. Though no telescope has ever directly observed this radiation, Webb's detection of faint energy signatures near black holes could offer the first indirect clues that Hawking's bold idea is correct. If so, it would mean black holes are not eternal prisons but cosmic fountains of paradox, slowly dissolving into the very universe they consume. These revelations force us to rethink the role of black holes in the cosmos. They may not simply be destroyers, devouring stars and matter. Instead, they could be engines of creation, regulating galaxies, driving star formation, and possibly even seeding entirely new universes. Imagine a multiverse where every black hole in our universe births another universe beyond its veil. Once considered pure science fiction, this idea now lingers as a serious possibility at the edge of cosmology. And Webb, with its unmatched vision, is giving us the first hints of how such radical ideas might one day be proven. What makes these discoveries even more profound is what they reveal about ourselves. The James Webb Space Telescope is not just a machine. It is the culmination of decades of human ambition, sacrifice, and collaboration. Thousands of scientists, engineers, and visionaries from around the globe worked tirelessly to place this golden observatory nearly a million miles from Earth at the L2 Lagrange point. Every mirror, every sensor, every algorithm was designed with one purpose: to expand humanity's gaze into the unknown. And now, as it captures light that has traveled billions of years across time and space, Webb is returning not just images but revelations. Each discovery is a reminder that the universe is not a cold, indifferent void. It is a story unfolding, a story we are part of. From the first humans who gazed at the night sky in wonder to the modern scientists decoding the secrets of starlight, we have always been storytellers of the cosmos. The James Webb Space Telescope is our latest, greatest storyteller. A time machine, a mirror held up to the universe and to ourselves. So, what lies inside a black hole? The answer remains incomplete. The singularity is still hidden, its truth locked away behind the event horizon. But thanks to Webb, the shadows are lifting. Each new image, each spectrographic reading, takes us closer to unveiling one of the greatest mysteries of existence. The journey is far from over. In fact, it has only just begun. With each discovery, the universe whispers a little more of its secrets. And as long as we keep building, keep dreaming, and keep looking up, the darkness will continue to give way to light. Stay curious, stay inspired, and keep watching the stars with Discovery Ed 2.0.